Okay, so now that you have seen a few examples on how to solve rational equations, by other people, I know that by now you're just boiled over by the thought of actually hearing me talk about it. So let me do a few with you here. The first one, I have 3 over m squared. And I'm going to set that equal to m minus 4 over 3m squared plus 2 over 3m squared. And all we're trying to do is we're trying to solve for m. What value or values of m will make this expression true? I could graph the left side of the equation in Desmos and then graph the right side of the equation in Desmos and solve it that way. But to be honest with you, sometimes these become so complicated that the answer may be way out there in the sense that you would have to do a lot of zooming and that type of thing. So I'm not going to do that, but you could actually do that if you wanted to invest the time, and wouldn't be a bad idea to maybe pause the video and try to do that on your own and then check your answer with what I'm about to do. So the first thing I'm going to do here is I'm going to recognize that I'm lucky on the right side because my denominators are actually the same. And since my denominators are the same, I'm going to keep the denominator, 3m squared, and I would just add the numerators together. So that leaves me m minus 2. Because negative 4 plus 2, right, is negative 2. So if I add the numerators, I get m minus 2. And on the other side, I have 3 over m squared. And now I could just cross multiply, right? I could just cross multiply those and solve, or I could go ahead and multiply both sides by the same thing. And I'm going to multiply both sides by 3m squared because I want to get rid of those fractions if I can. And if I multiply both sides by 3m squared, watch what happens here. On the right side, the 3m squared cancels out the denominator. And on the other side, the m squareds cancel out. And that leaves me, let's see, 3 times 3 is 9. So 9 would be equal to m minus 2. And if I add 2 to both sides, 9 plus 2 is 11. And m minus 2 plus 2 would leave me m. So it looks to me like the answer is 11. So that takes care of my first example. And let's do another. Suppose I have something like this, x minus 6 over x is equal to x plus 4 over x plus 1. Okay, we have several different ways that we could solve this. I think what I want to do is I want to rewrite this 1 as x over x, because isn't it true that x divided by x is the same as 1? Now, why would I do that? Well, if you think back to this problem over here, remember, the denominators being the same does give us an advantage. So all I did was I rewrote the 1 as x over x. And now if I multiply every term by x, this term and this whole term here gets multiplied by x, and this whole term here on the left side gets multiplied by x. Watch what happens here. Those x's will cancel, these x's will cancel, and these x's will cancel, And now the fractions are gone. That's going to leave me x minus 6 is equal to x plus 4 plus x. And if I add x plus x, that's going to give me 2x. So let's see, that's going to be x minus 6 on the left. And on the right, that will leave me 2x plus 4. If I subtract an x from both sides, this x will become, let's see, that will leave me a negative 6 on that side. If I subtract an x from 2x, that's going to leave me x plus 4. And then if I subtract 4 from both sides, that will leave me x is equal to negative 10. So there's the solution for the second one. Okay, let's look at one that's a bit more difficult. And I'm going to do 1 divided by 2n plus 1 over 4n squared and let's set that equal to 1 over 4n. And remember, my goal here is to either get a common denominator or maybe get rid of all of the denominators. And let's see, 4 goes into 4, 2 goes into 4, and n squared go into n squared. So I think I'm going to multiply by 4n squared for all terms involved. I'll multiply that by 4n squared. I'll multiply this 1 by 4n squared. And I will multiply this 1 by 4n squared. And let's see what that would give me. Well, at this point, I know that I can, this 4 here will cancel this 4. This n will cancel out one of these n's and leave me just an n on the right side. So let's see, I've got an n on the right side. And luckily, this entire denominator here will cancel out that factor. So that leaves me plus 1. And then let's see, this 2 will go into this 4 twice. And this n will go into one of these n's. So that will leave me a 2n. So now I have 2n plus 1 is equal to n. And if I subtract 1 from both sides, that will leave me 2n is equal to n minus 1. I just subtracted 1 from both sides. And then now I'm going to subtract an n from both sides. So it looks to me like 2n minus n is 1n. So n would be equal to negative 1.